Again, I will go back to chapter 3 and we will talk more about adding by component. Okay, then now here, if I want to add and subtract or add or subtract, and I need to do that instead of doing that method, which is the graphical method, which is really a little bit more difficult, then I need to use the component. Now the components means I will split my vectors or my vector into, okay, one, we call it projection, or it is a component along X and the other component along Y. Then it is no longer in the XY plane. It is now divided into two. Like I can simply say this is A equals AX plus AY. Now this knowledge, it is related to trigonometry, where we were able to say sine is the opposite divided by the hypotenuse, the cosine is the adjacent divided by the hypotenuse, and the tangent, it is the opposite divided by the adjacent. Then I will say here, we can, then now based on this, I'm gonna add also another page here. Okay, if I want to have my vectors here, in general, this is, okay, this is my vector A, and it has a magnitude of A, and this angle here is theta. Then that AX here, it is A, the magnitude, I can write it like this, times cosine the angle, and the AY, it is the A sine theta. And for example, if my vector is, my vector which is A, it can be expressed as 4. It's displacement and 25. This means that it is making this type of angle with respect to the x-axis. Then I will say AX is going to be 14 times cosine 25. And if you will do your, of course here your angle should be in degrees. Okay, then you're gonna have that 25 cosine the angle of 25 times 14, and that is gonna give you 12.7 based on significant figures. I can do the AY, which is the 14 times sine 25, and that is should give us 5.92 kilometers. I can now write A in two forms. One of them is two alternative methods, 14 and 25 degrees, or in terms of it is components, the first is the X and then the Y. Oh, this is, come on, yes, 12.7 and my Y. And again, as I said, 3 significant figures. Now, what if you, what if the angle you have is this one? Okay, you can either reverse. You can say AX is going to be A sine theta and AY equals A cosine theta. Or if you are not comfortable with that, you can find this one, which is going to be 90 minus theta, and you will use cosine for, the x and sine for the y. Now, I will say I am more comfortable with, you're gonna see me do this all the time. I will always consider my angle with positive x-axis in the counter clockwise direction. And because of that, always my angle, my AX is going to be A cosine, and my AY equals A sine. Let me show you what I mean by this. For example, if I have a vector like this is my A here, and this one was given to me as 30. I will not consider the 30. I will consider this angle here. And then my AX is going to be my A times cosine 180 minus, which is 150. And AY is going to be A sine 150. I like this method because you don't have to think of if your component is positive or negative. By the calculation, you will get the negatives and the positives as you wish. Okay? Then, like anytime you're gonna get your vector, wherever it is, and maybe this was given as 20, you wanna consider this angle, which is gonna be 270 minus 20, which is 250. But of course, you have the option to do whatever you like. Now, of course, here, showing you that depending on where your vector is, you are going to get different signs for the components. For example, in A, you have AX is positive and AY is negative. In B, you have A negative and B is negative. And this is when it is in the fourth quadrant. The third quadrant. The other one, the previous one, A, when the vector is in the fourth. And for the second quadrant, of course, X is going to be negative and Y is going to be positive. In the first quadrant, you will find that two components are really positive. Now, when we add vectors, then I can simply draw the diagram and then add the vectors graphically, or if I like, I can choose X and Y and resolve the vector into X and Y components, and then calculate each component and then add the components in each direction. And then to find the magnitude of the resultant, you will find the Pythagorean theorem, V equals square root of Vx squared plus Vy squared the square root, and this is to find the tan, the angle. Okay, and I will say this is like here a demo for doing this. Okay, I like always to do like just this is like I will show you an example here, but this is here when you draw the diagram, you can see A and B here. You can add them graphically so that you have a feeling where is your resultant and how much it's going to be. And then you can have your X and Y axis and show the components. Then you are going to add the x's together. Cx is going to be AX plus BX, and CY is going to be AY plus BY. And then finally, you need to get what is gonna be the length or the magnitude. I like always to say magnitude and direction of the vector. Okay. Okay, I want to show you here how I'm gonna solve one problem. Then I'm gonna add here two vectors. I will just, the first thing is, okay, add okay, and this is my A, and my B is and when I will indicate these angles here, this means that I will, by this method, that this angle here, it is, as I said, with respect to the positive x-axis counter clockwise. Okay, first I want to draw my x and my y. And here I will have, okay, let's roughly, this is 725. And the other one is 120. Then I have here 60, then it's gonna be something that is gonna be this is my B. Okay, in order for me to find that graphical, okay, like I want to have here more space, then I will say this is my A. Of course, I should use a ruler and a protractor. This one here, on that tab here or head, you're gonna make the axis again, and then you're gonna draw that is, let's say 15 roughly, okay, I will say. And then your resultant is gonna be that green. Then this is my R. Let's now try to find if this is gonna be correct. Okay, and then I usually like to have my vectors. I don't have enough space here. Then I will have here and it depends how many vectors you want to have, and magnitude, direction, and then X and Y. All right, then here I will say this is my A, this is my B, the magnitude, and it is in meters here. I have 1.7 and one is 15. Now the angles here, or theta in degrees, this one 25 and that one was given as 120. This is the X component and this is the Y component. This is going to be here 7 cosine 25, and that is going to be 7 sine 25. This is going to be 15 times cosine 120, and this is going to be 15 sine 120. Now I need to use my calculators first, and I will say, okay, 25 cosine times 7. You're going to get this is as 6.3. For the second one, you're going to have sine times 7, and that is going to be 2.95, which means this is 3. And then 120 cosine times 15. This is going to be negative 7.5. And for 120 sine times 15. And you need to check the common sense thing, if it is like making sense. Here, I shouldn't round in the intermediate stages. But for me, I will round because like I want to save time. But usually you don't, okay? You will round in the last calculation. Then here, I will add them, okay, with a sign. And then 3 plus 13, it is 16. Then this is my Rx, and this is my Ry. In order to calculate R, I will say this is going to be Rx squared plus Ry squared. And that are, okay, you need also to find the angle as well.